That wraps up our announcements for today. Have a great, great Thursday, and let's make your mark, Mustangs.
All right, because of the author talk at 10 o'clock, we're gonna change classes early here at school. So we're not going to have a morning meeting. We're gonna go right into math. So if you don't have paper and pencil, please get out paper and pencil. Layla, you need to go to the library and finish that up. When you get finished, you can come back, okay? Dakota, you need to go to the library and do Imagine Math, the benchmark. Do you need your login?
Yeah.
So get paper and pencil if you're at home. Sharpen it, there's sharpener right here. Right next to Katie, yeah. Katie, you need to go to the library and do this as well. Do you need your login? Woohoo, got 3 more off my list. All right. Can you see that at home?
Yeah.
All right, I'll give you 2 minutes to work on it. Go. Think about, what do you see? What shapes do you see? How do you find the area of those shapes? Can you see from there, Arthur? Okay. As long as I stay out of your way. What shapes do you see? Do you need paper? What shapes do you see? Well, I see one square, the 10 by 10 piece off to the side. What are the other 2 shapes? You see two more shapes? Do you see a rectangle inside of a rectangle? Okay. So what are we wanting to do? What are they asking us to find? Uh-huh, okay. Walkway and patio, so. You got about 30 seconds more. What do you see, Jaden? What shapes do you see? Do you see a rectangle inside of a rectangle? Hmm? Okay, do you see a square off to the side? Okay. Alright, so we're being asked to find this area and that area, correct? Is that what the problem's asking for? Okay, does everybody understand that much? Okay, so we see, do you see two rectangles, one inside the other, and then a square? Everybody see that? Okay, so we have the walkway, the outer edge of the walkway makes a rectangle. The pool is a rectangle, and then we have this square over here. Well, can we find the area of the square real easy to start with? What's the area of the patio? Hmm? 100 feet squared, right? How did you get that, Alan? Huh? How did you get 100 feet squared? Oh, Michael, how'd you get 100 feet squared? 10 times 10, like times width, base times height, side times side, however you want to think of it. All right, now, the little rectangle, the pool, is 16 by 12. So what's the area of the pool?
192 feet squared.
Okay. Now, we only want this. So how are we going to find that? We know that this inside here is 192 feet squared. So how are we going to just figure out the walkway? What do you think?
Figure out the entire area of that big square and then subtract the pool.
So if I take this rectangle and then subtract out the pool, is that going to leave me the walkway? Okay, so now we need to figure out the measurements of the outside of the walkway. So how long is this right here? Well, it's 16 from here to here. Then how far is it here?
See, Layla Workman
She is in the library.
doing the Imagine Math?
Uh-huh.
Oh, okay,
Katie's in there and Dakota's in there.
I just need Layla, but thank you.
Uh-huh. I sent her. So is this 4 here? Is this 4 here? So how long
Yeah.
is this line here? 24. Okay. Is this 4 here? Yes. Is this 4 here? So how long is this whole line?
20.
20. So what is the area of the big rectangle?
480.
480. So you told me I am going to take this area, subtract out that area.
Mm-hmm.
So what do you get when you subtract those two?
288.
Uh-huh. So that means the walkway has an area of 288 feet squared. We want the walkway and the patio, so our answer is going to be
388.
388 feet squared. Okay? Makes sense? Do you remember this problem from the benchmark? Some of you struggled with it. Does it make sense now? Okay? If you kind of think of this like a cookie cutter, we're cutting out the pool, so we're subtracting it. Maybe that'll help you. Or a donut, you're taking the hole out. Okay? All right. So let's move on to our lesson. This is lesson 2, reasoning about contexts with tape diagrams. So our learning goal is let's use tape diagrams. Oh, tape diagrams have come back to make sense of different kinds of stories. So I would love it if at the end of the lesson you could explain how a tape diagram represents parts of a situation and relationship, and you could use a tape diagram to find an unknown amount in a situation. You can reason through the tape diagram to find a solution. All right, that's what I would really like you to get out of today's lesson. All right, does anybody have any questions from the activities or the slides that you were supposed to do before you came to class?
No.
No? All right. Well, I'm going to go over one of the activities. So I'm going to go over this one. Noah and his sister are making gift bags for a birthday party. Noah puts 3 pencil erasers in each bag. His sister puts X stickers in each bag. After filling 4 bags, they have used a total of 44 items. So I had asked you in the slides to be prepared to share your tape diagrams. So does anybody want to share their tape diagram? Michael? No? Anybody at home? All right,
I didn't answer any of them.
I'm sorry, what?
I just went over them. I didn't answer any.
Okay, Hunter, why don't you explain to me what you drew? Hunter, explain what you drew and I'll draw what you did. You gotta unmute yourself.
Put 44 above that.
Okay, so this whole thing is gonna equal 44. Okay,
And then, put 3 squares or 3 spots of that rectangle. It's gonna be,
why did you put 3
because it's 3 pencils eraser in each bag.
in each bag? How many bags are there? 4 bags. So wouldn't I take and split this into 4? Each of those is gonna represent a bag?
Yes.
Okay, and then Noah put 3 pencils in each bag. Okay, does that represent Noah putting 3 pencils in each bag? Okay?
Yeah.
His sister put X stickers in each bag. We don't know how many stickers she put in each bag. So does that get added to the 3 in every bag?
Yes.
Yes. So we're gonna put plus X, plus X, plus X, plus X. Then we're gonna come over here on the side and we're gonna say X represents number of stickers. You always have to tell me what the variable represents. Okay? So why did Hunter tell us to put 44 up there? Where'd the 40?
That's total.
That's the total number of items in the 4 bags, right? So does that picture represent the story? Okay, now, how could we solve this?
44 minus 3 times 4, and then 88.
Okay, so you're saying I can do 44, take away 3 times 4, that's your 3's. You see that? So that's 44 minus 12. That's 44 minus 12, which is gonna give me what?
$32.
32. Yep. This layer can't subtract. There we go. All right. So now we have what left?
Divide 32 by 4.
Divide 32 by 4. Why did you divide 32 by 4?
Because there's 4 bags.
Because there's 4 X's, right? Okay. Is there another way to think of it? How many items are in each bag? What am I going to do with that 44? Divide it by, not 3, by 4. Could I take the 44 and divide it by 4? That tells us there are 11 items in each bag, right? Okay.
Mm-hmm.
Then I'm going to think 3 plus what equals 11. So this ends up being 3 plus X equals 11 because this right here is 11, this right here is 11, this right here is 11, and this right here is 11. So 3 plus what equals 11?
8.
8. Did we get the same thing doing it this way? Yes.
Yes.
Okay, either way of thinking it works. Okay? Now, what does the 8 represent in this story? 8 what? 8
Stickers.
stickers. So there are 8 stickers in each bag. Okay? Make sense? All right. Let's try number 2. Noah's family also wants to blow up a total of 60 balloons for the party. Yesterday they blew up 24 balloons. Today they want to split the remaining balloons equally between 4 family members. Okay? So this story is about
Balloons.
balloons. Okay? What can we count or measure? Like
60.
60 balloons. Yesterday they blew up 24 balloons. Today they're going to split the remaining balloons between 4 people. Okay. What's my total? What's the total? What's my tape diagram going to equal all together? 60 balloons. Okay, so this needs to equal 60. And it doesn't matter if you put it on top or on bottom. All right, now, what happens? They blew up 24 balloons. Did each person blow up 24 balloons, or do we just have 24 balloons? We just have 24 balloons. Now what happens?
Now they want to divide the remaining against 4 family members.
Okay, so now we're gonna take what's left, divide it by 4. We don't know how much each person blew up, so that's gonna be our variable. So X is, I'm just gonna abbreviate, represent number of balloons each person blew up. Okay? Does the tape diagram make sense to you? You see how it's different than the previous one? Okay? All right, let's reason our way through this. What do you think we're going to do first to figure out what X equals?
60 minus 24.
Yeah, we're going to take away that 24. That's going to leave us with just the X's, right? Okay, so 60 minus 24 is 36. So that means if I take this right here, 4 X's equals 36. So how am I going to figure out what 1X is?
We're going to divide 36 by 4.
So I'm going to take 36 and divide it by 4, and that's going to give me 9. What does the 9 represent? So you would tell me each person blew up 9 balloons. Questions that you have in your mind about what we just did? Where did I lose you if I lost you? Jaden, we're good? Okay. Anybody at home?
No.
All right. No, I don't want to save that. There we go. All right, question 3. Noah's family bought some fruit bars to put in the gift bags. They bought 1 box each of 4 flavors: apple, strawberry, blueberry, and peach. The boxes all had the same number of bars. Noah wanted to taste the flavors and ate 1 bar from each box. There were 28 bars left for the gift bags. Okay, what do you think? Well, we're going to start with a tape diagram. What are we going to do with it? What am I going to do with it?
Divide it into the 4 flavors.
Divide it into the 4 flavors. Okay? So we used this. What else can we countermeasure? Oh, what did he do?
He ate 1 out of
Okay.
each box.
And then we know there were
28.
28 bars left. Is that our total? Is this what our total is going to be, 28?
Yeah.
Okay. Did they put an equal amount in each bag? Do we know what that amount was? Okay, so they started out by putting an equal amount in each bag, but we don't know how many. Then what did Noah do? He ate 1 from each of different flavor. So would we say -1?
Yeah.
Would that make sense? Okay,
Mhm.
if we think of this as the 4 boxes, okay, and after he ate one, there were 28 left total. Okay, did we understand how we drew the picture?
Yes.
All right, so how do you think you would solve that? X represents the number of bars in a box. Okay,
I would divide 28 by 4 and then subtract 4.
okay, 28 divided by 4 is 28 divided by 4.
7.
7. So that means each one of these is worth
7 bars.
7. Do you agree? Does that make sense?
Yes.
Do you see the 4 groups of x minus 1? Okay,
Mhm.
so we figured out what one group would be worth. Okay, so if we want x minus 1 to equal 7, what is x going to be? What minus 1 equals 7?
So 8.
8. If I plug in 8 here, do I get 7?
Yeah.
Is that a true statement? So our x is 8.
8. 8.
Now, what does that 8 mean in this story? There are 8 bars
Box.
in a box,
And a box.
okay? Questions you still have about what we just did?
No.
No? Is there another way to solve it? Could I have added 4 to that
Yeah.
and then divided by 4? Yeah.
Yep.
To me, it makes more sense to look at it as they're all the same group, start by dividing by 4 and then figuring it out. Either way works. All right? All right, so what are some ways that the tape diagrams gave us information about the story? So let's look at this first one. What could the story be for that tape diagram? What could the story be? Think gift bags.
Well, it's the same story as question 1.
It is the same story as question 1. So what does each one of these blocks represent from question 1? The bags, okay? Then the 3 was the pencils he put in, and the X were the stickers that they put in. What does the 44 represent? The total number of items, okay? Let's look at this one. This was the balloon problem.
Yep.
Okay, what did the 24 represent?
The
Number of balloons that were already blown up, right? What does the X
Yep.
represent?
amount of balloons that they wanted to give to their family.
Okay, that each person in the family needed to blow up. What did the 60 represent? Total number of balloons that we wanted for the party. All right? Does it make it more, does the tape diagram help make more sense of the problem? No? Some of you can probably jump straight to the equation and that's fine. Some of you, the picture might help you. Okay? All right, let's start with some practice problems. So make sure you have paper and pencil so that you can write them down. All right, table shows the number of apples and the total weight of the apples. So we have 2 apples and they weighed 511 grams. We have 5 apples and they weigh 1,200 grams. And we have 8 apples and they weigh 2,016 grams. We're being asked to find 6 apples. Estimate. So what kind of strategies do you think?
You could divide 551 by 2 and then figure out how much 1 apple weighs.
Okay, and see if it's consistent. Let's try that. So take out your calculators. Do 511 divided by 2. What do we get?
$225 or 255.5.
255.5. Okay. Take 1,200 divided by 5. $420. All right. Not seeing a consistent, are we? Okay, take 2,016 divided by 8. $256. 52. All right, tell me about apples. Does every apple weigh the same?
No.
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 Okay. So we wouldn't expect to have a COP. But this is telling us what 1 apple weighed. And they are asking us to estimate the weight of 6 apples.
I'm looking at the weight of apples for 5. That doesn't make sense. 420. That wouldn't make sense.
Okay, so did we get a wrong number here?
I did 1,200
Okay.
divided by 5, and I got 240.
Okay. You're right. That makes more sense. All right, so what are they all around?
200 to 250 grams.
They're right around 250, aren't they? Could we say 250 is kind of like the average? All right, so if we do that, can we estimate the weight of 6 apples? Can we take 6 and multiply it by that 250? What does that give us? 15? Did I do that right? Would that be a good estimate?
Yes.
What else could we have done? Could we have taken this information and multiplied it by 3? We want to get to 6,
Yeah.
right? Could we have taken that and multiplied it by 3? Would we be close to the 1,500? Mm-hmm.
We get close to that. We get 1,533.
Okay. So remember, apples don't all weigh the same. So either way would give us a reasonable estimation, right? Okay?
Yes.
So there's not a true COP, but we can use that information that we found for how much each apple weighed to figure out how much 6 apples would probably weigh. Okay? Questions you have about that? All right, who needs more time? Nobody? All right, I'm gonna erase it. Select all the stories that this tape diagram can represent. Well, let's talk about the tape diagram first. What do you see? What do you notice about that tape diagram? The total is 87. What else? What happens to that 87?
It gets divided into 5 different parts.
Okay, we've got 5 different parts. Are they equal?
No,
No, only 4 of them are equal, right? And then we have a definite 39. Okay, are these all the same? Are these going to be the same number?
yes.
Yes, that's why they're equal in size and they all have an X inside them. All right? So let's see what works. There are 87 children and 39 adults at the show. The seating in the theater is split into 4 equal sections. Would that work? Is that a picture of that?
No,
No, it's not. Why not, Caitlin?
because there's 39 and that's not equal to the 4 equal parts.
Okay. Makes sense what she's saying. All right. Anybody have a clue of what that would look like? What do you think that would look like? We have 4 sections, right?
Mhm.
And how many people do
The
we
total
have?
is 39.
Well, what is the total actually?
Well,
87 and
39.
39, so that is 8, 10, 11, 12, 126. And then we're gonna have X plus Y. We have 2 variables.
Mhm.
We have X could be the children, Y could be the adults.
Adult.
But they don't even tell us that the same number of children sit in the same spot, in the same section, and the same number of adults sit in each section. So they don't tell us that. So we know it's not that, but we can't really even draw this. Okay? All right, so A doesn't work. How about B?
Yes,
Do we agree with Caitlin? Caitlin said yes, B works. Does anybody agree with her? So you all disagree with her? Why do you disagree with her? Thomas, why do you disagree with her? I need somebody to tell me why they disagree with her. Since nobody agreed, why do you disagree with her? What in the tape diagram doesn't work according to the story? Is the total wrong? What's the total in the story? There's 87 first graders.
87.
Okay, do we have a total of 87 in that tape diagram?
yes.
Okay, that matches. What else happens?
39 students got picked up.
39 students got picked up. Well, that's where the 39 came from. This is the 39 that got picked up. And then what happened to the remaining students?
They got filled with the 4.
They got put into 4 groups for an activity. Does this show 4 groups, equal groups?
Yeah,
Okay, so do we have, these are the kids that were staying, these are the kids that were picked up, and this is the total number of kids in first grade?
yeah.
Okay. Do you still disagree, or do you now agree? You agree? Hello? Wake up. Do you agree? Give me a thumbs up if you agree. Yuvia agrees. Okay. So B works. All right, look at C. Lynn buys a pack of 87 pencils. She gives 39 to her teacher and shared the remaining pencils between herself and 3 friends.
Yes.
Does C work? Why, Michael?
Yes.
Because Lynn has a total of 87 pencils,
Uh-huh.
and she gave it to 30, she gave it to 39.
Okay, so that's
Yes,
why
because
there's
she
39 there?
39 to her teacher, and she shared it with the other 4 people that are X's.
Okay, so we got that 4 groups because this equals 4 people got an equal amount of pencils. Okay? Anybody question, anybody disagree with their explanation? All right, did anybody see it a different way to explain it?
I just explained B.
Okay, how about D?
No.
Andre buys 4 packs of paper clips and 39 clips in each. Then he gives 87 paper clips to his teacher.
No, that's not gonna equal.
Yeah, that's not, okay. All right, how about E? Diego's family spends $87 on 4 tickets to the fair and $39 for dinner.
Yes,
How much did they spend altogether?
87.
So this whole thing would be 87, right? Okay, the 39 is gonna represent dinner, and then what did they buy? And you would assume that the tickets cost the same, wouldn't you? So this is the 4 tickets, this is dinner, and we know they spent $87. So does E work? Yes.
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 Okay. Questions you have on that?
I do have one question.
Yeah.
So they spent $87 on tickets, 4 tickets.
No. Diego's family spends $87 on 4 tickets to the fair and a $39 dinner. So this is the 4 tickets
Yeah.
and dinner.
How would that equal up to 87?
It's not saying they spent $87 on just 4 tickets. It's saying, here's your total, and they bought 4 tickets and dinner. Read it again. Okay, does that make sense now? Okay. All right. Problem 3. Andre wants to save $40 to buy a gift for his dad. Andre's neighbor will pay him weekly to mow the lawn, but Andre always gives a $2 donation to the food bank in weeks he earns money. Andre calculates that it will take him 5 weeks to earn the money for his dad's gift. He draws a tape diagram to represent the situation. Explain how the parts of the tape diagram represent the story, and then how much does his neighbor need to pay him each week to mow the lawns to be able to buy the gift. All right, what does the 40 represent?
$40 that he needs to buy the gift.
Uh-huh, the 40, the total he wants to have. All right, what does the X represent?
The amount of money he gets from mowing the lawn.
The amount of money he gets for mowing the lawn. Okay, why do we have 5 boxes?
Because it's gonna take him 5 weeks.
Okay, why minus 2?
Because he's given $2.
Because he donates $2.
Good, Jason. He donates $2 every time he mows the lawn, right? Okay,
Mhm.
all right, any questions about why the tape diagram is the way it is? All right, let's reason our way through it. How could we figure out how much the neighbor is gonna pay him? Because X represents what?
The amount of money he gets for mowing the lawn.
All right, so what do you see? Do you
I'd say
see
40 divided by 5.
Do you see 5 groups that are equal and they equal altogether equal 40? Do you see that? 5 groups, so that's minus 2. So could I take the 40 and divide it by 5 and figure out what each of these equal? So what is
Yes.
each block gonna equal? $8. Okay. So each block equals 8.
$8.
Is that how much he
for
gets-
each one.
Is that how much he gets paid to mow the lawn? $8.
Yes.
Is that what it's saying? Look at it again. Is X minus 2 what he gets paid to mow the lawns? Or is X what he gets paid to mow the lawns? X.
X.
Well, X minus 2 equals 8. I now have this. So X can't equal 8, can it?
X is 10.
X is 10. Jaden, how is X 10? Good job.
X minus 2 is 8.
Mm-hmm. So something minus 2 is gonna equal 8. So what does he get paid? He gets
He
paid
gets paid
$10 to mow the lawn. Make sense?
Yep.
Okay. Yes,
Where's
Jason?
the lunch sign up?
Should be an icon on your iPad.
Nothing.
They take it off. Okay, then go to the Tucker Creek website. And you find it fast, and it's there. All right. Questions you have for me? So how much does Andre's neighbor pay him each week to mow the lawn? His neighbor,
$10.
uh-huh, pays him $10. You always have to answer the question in a complete sentence. You can't just tell me X equals 10, because I'm gonna say 10 what? What does that 10 mean in this story? Okay? What questions do you still have? Starting to make a little bit of sense? Okay? We're gonna build on this, so I wanna make sure we got a good foundation. Okay, who needs more time? Nobody? All right. Question 4, without evaluating each expression, determine which value is the greatest. Explain how you know. So without, so what do you think they're wanting? Maybe we could just figure out if they're positive or negative. Maybe that would help. All right. So A, would A's answer be a positive or a negative? 7 5/6 minus 9 3/4. Remember, subtracting a positive is the same thing as adding a negative. So which is bigger? Negative 9 3/4 or positive 7 5/6?
9 3/4.
So this answer is gonna be a negative. Let's see if this helps. I mean, this is just a strategy. All right, negative 7 and 5/6 plus negative 9 and 3/4. What's that answer gonna be, positive or negative?
Positive.
Let's think about it. If I go negative and 7 and 5/6, I go that way, right?
Mhm.
Okay. Which way am I gonna go for negative 9 and 3/4? Am I gonna keep going this way? So how is my answer gonna be positive? Is my answer positive?
No.
No, it's negative. A negative times a negative is a positive. But a negative plus a negative is a negative.
Negative.
Okay, so this one's negative. Well, so far that hasn't helped us figure out which one is the greatest. All right, this one we look like we've got a negative 7 and 5/6 times a positive 9 and 3/4. What's that gonna give me?
A negative.
A negative. Still hasn't helped me figure out which one is greatest. They told me not to evaluate, don't solve it. All right, now we have a negative 7 and 5/6 divided by a negative 9 and 3/4. What's a negative divided by a negative?
A positive.
A positive.
Positive.
So now can we answer the question?
Yes.
Which one is greatest?
D.
D has to be greatest because it's the only one that's positive.
It's G,
Hmm?
it's G,
There is no G. Are you just trying to be funny?
sure.
Okay. So did our strategy work? Yeah. We were
Yes.
able to find an answer.
That makes it a lot better.
Okay. Can anybody think of a different strategy that might have worked?
You could work out all the problems and see
Well-
if they're negative or positive.
It says not to. Okay? But you could. I mean, nobody would know the difference. All right. Last one. Solve each equation. 8 and 5/10 times negative 3. Tell you what, I'm gonna give you 1 minute to solve all this. Those of you at home, put your answers in the chat, but do not hit enter. Just put A equals B equals C equals D equals. Okay, those of you here, go ahead and sign into the Zoom meeting and you can do the same thing and I'll show you something cool. Okay, do not put your answers in the chat, but do not hit enter until I tell you to do it. Get out of your way. I've got to let everybody in. Let me change my settings on the chat. There's Lee. Okay. Oops, Gracie got kicked out. I'm trying to get back in. All right, put your answers in the chat. A equals B equals C equals D equals, but don't hit enter. I'm gonna change it for a minute. Just put in what A equals. Just write in what A equals. So erase what you got and put what A equals. Okay, put it in the chat. What did you get for A? Okay, I'm gonna give you, when I get to 0, you're going to hit enter and watch the screen, okay? So 5, 4, 3, 2, 1, hit enter. All right. Good, 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 good. Okay, we want an answer, Caitlin, not just positive or negative. Nellie, we want an answer, not just positive or negative. Good. All right. Put in.
I just forgot to put negative.
Okay.
I should figure it out there.
Dakota, it's going to be negative because a positive times a negative is a negative. Okay?
Yeah.
All right. Put in your answer for B. Do not hit enter. Put in your answer for B. Put it in. Okay. 5, 4. You need a little bit more time? Who needs more time?
I wasn't even able to get into the Zoom meeting.
Okay, here you go. You're in the Zoom now, Alan. All right, here we go. 5, 4, 3, 2, 1, enter. Good. -4. Awesome. -7 plus -4 does in fact equal -11. Good. All right. Put your answer for C in. Yeah.
Is it -4?
Yeah, let's look at it. Thank you for questioning that. Let's look at it. If this will cooperate. If I go here and I go -7, where do I want to end up? I want to end up at -11, right? So my answer is going to be -11, which is right here. So what do I have to add to that to get to -11? I have to add a -4, okay? Make sense? Good job for asking, thank you. All right, we ready for C? Put your answer for C in. Okay, here we go. 5, no, I'll give you a minute. Well, 30 seconds. Evan, do you have a question or is that an old hands up? All right, here we go. 5, 4, 3, 2, 1, hit enter. Oh, I got 12, a -12, and an 18. All right, let's look at that one. Let's plug in 12 there. 12 minus -3. Subtracting a negative is the same thing as adding a positive. So 12 plus 3 is 15. Is that what I needed?
Yes. 3 is 15.
Okay. Could I have reasoned my way through it? Yeah. Okay. I know I need to go somewhere to end up at 15 is my answer. And I've got -3, so we know we have to go that way. Okay? All right. Do we need time for D? Are we ready to put it in? All right, put in D. Put in D. Are you good, Jason? Okay. Here we go. 5, 4, 3, 2, 1, go. Good. Good. This is more multiplication. So what times -4 is gonna give me a positive 32? It's gotta be -8. Good job. All right, next steps. I liked doing that. All right, first thing, upload a picture of what you just did, your practice problems, onto the practice problem Google Slides for this week. Independent work, you have a Google slide to do. There wasn't a Khan Academy that went with this, so we made up something for you to practice independently. Remember, you need to get 2 lessons completed in Imagine Math this week so you can be a star. And before you come to class tomorrow, complete lesson 3 slides and activities. Okay, questions you have for me? Those of you at home, you will go to second core at the same time as usual.
What
Bye.
was the answer to number 6?
Number 6.
Yeah.
We didn't have a number.
Miss Laird, have a great day.
You too. We didn't have a number 6.
Well, I have one on my track.
Yeah, it didn't show up on the teacher version.
Okay, so
I can
just
tell
need
you-
to worry about it.
Let me tell you what the answer is.
Okay.
It is B, C, and F.
Okay, thank you.
You're welcome.
Got lucky.
Because I saw it and I was like, did we go over number 6?
No, we didn't.
Yeah.
All right.
Well, I'll see you later.
Bye.
Sorry.
Bye. All right, you can start working on that independent practice, which is a Google slide. Did everybody find it? If you didn't take yesterday's test, I need you to do that. So you've got about 15 minutes before we change classes.
Wait, isn't this thing at 10?
Yeah, but we're changing classes at 10 till 10 because Miss Wagner's class is going to the library to watch it. Did everybody find the independent practice? Yeah, 3 days.